In this video, I want to supplement some of the content that was described in the textbook related to your types of variables or in type of data. So, just as a review, we saw that there were two types of variables that we will study in research. One type of variable is a qualitative variable. Some individuals like to call these variables qualitative. And these variables consist of values that can be placed into non-numeric categories, all right? And so some examples of qualitative variables are variables such as political affiliation, meaning what political party you belong to. I can place individuals in one of those categories based off of the name of that party. An individual's race or ethnicity is another type of qualitative variable. And I wanted to include a qualitative variable that uses numbers, but the numbers don't have meaning in a numerical sense. And that is something like your social security number. We don't add social security numbers together and get anything meaningful, but we use it to identify a person. Now, it is an identifying type of qualitative variable, but we can think of it as a qualitative variable. The other type of variable are those numerical variables that we may have in research, and those are called quantitative variables for representing the quantity of something. And so here it says that these variables consist of values that represent counts or measurements. And so a few examples that I have up here are things like a person's or an individual's year in school, a temperature of a classroom, or an individual's GRE score. Each of those variables represent the amount of something that gives a measurement, and those amounts or measurements are numerical in nature. So that makes it a quantitative variable. Just to give a little bit more information about quantitative variables, and then we're going to get into some other stuff, we can meaningfully compare values of quantitative variables on number lines. And so that's another way that differentiates them from qualitative variables. We're just grouping or categorizing individuals with qualitative, but with quantitative, we have the amount of something, which an amount can be put on a number line. Also, it makes sense to do things like add or subtract, multiply or divide for some of these quantitative variables. That means we can do arithmetic or arithmetic operations. And with that, since they're numerical, we can find things like numerical summaries, like finding the average weight or the maximum and minimum value of weight for a classroom of students. And then we can also do things like create graphs like a histogram, and then calculate something like a standard deviation. And it has numerical meaning. Now, when it comes to quantitative data, we can look at the values that that variable takes on. Remember, a variable is any characteristic or trait of an individual, right? And with quantitative data, qualitative also, it's called a variable because individuals vary on those variables. And the specific amount for a quantitative variable will be identified as the value. So this says types of values. For instance, weight. An individual's value on weight may be 133.7 pounds. Another individual's value on a variable weight may be 223 pounds. All right. And so we can identify or further classify quantitative variables based off of whether they are continuous or discrete. Now, this can get a little theoretical, but we'll talk about it a little further. For continuous quantitative data or quantitative variables, the values can take on any value in an interval or on a certain range, right? So when I think about the height of a person, all right, I don't know what's the highest, the tallest person in the world, but if this is ground level, then a person's height can be any height from ground level up to a certain point. I don't have to skip over different levels. That's what make that makes the variable height continuous because I can take on any value on an interval. Another way of thinking about that is that that variable can have any number of digits after the decimal, right? So a person's height can be 5.6789346 inches, right? Now, our measurement instruments may not go that far, but technically, a person's height can be that value that I just randomly called out. That's for continuous. For discrete quantitative data, the values are only particular values on a range, right? So they can take on particular values, not all values on an interval or for a range of values. And because it can only take on particular values, those values can be counted or listed. An example of a discrete quantitative variable is something like number of students in a classroom. You're not going to have 3.5734836 students in your classroom ever, right? You're going to have 3 or 4 or 5 or 6, more like 20 or 25 or 20, so on and so forth, those whole numbers. So discrete means if we were to put it on a number line, we could have a value and then we'll skip over a little space and there's another value. Skip over another space, there's another value. And we say it's countable because since there are spaces, we can actually count if we had time to count all the values that that variable can take on, right? So continuous takes on any values on an interval. Discrete, it can only take on specific values within an interval. Another example that I gave here is shoe size. Think about a manufacturing company that makes shoes. Their shoe sizes come in things like a 10, 10 and a half, 11, 11 and a half, 12-inch shoe, right? Now, if I were to think about the length of a foot, I would say that that's continuous, but a shoe size, the way we manufacture shoes, that will be considered discrete. All right. A lot of times I say, oh, if it's the number of something, a lot of times in research, we'll see something like number of students or number of, let me see, times a student has a certain behavior, things like that. Those would be considered discrete. A lot of physical things are continuous. All right, so that's looking at the values of quantitative variables. Now we're going to switch to the levels of measurement. All right, how data or variables are measured. There are 4 of these, and they apply. 2 of them apply to qualitative data. 2 of them apply to quantitative or numerical data. The ones that apply to qualitative data are nominal and ordinal levels of measurement, and those that apply to quantitative data are interval and ratio levels of measurement. So let's talk about the nominal level of measurement. If a variable places individuals into categories that have no natural ordering or ranking, then I'm going to call that level of measurement nominal, right? So nominal is equivalent to saying in name only, right? We're just naming or putting individuals into categories. Some examples of some nominal variables that are measured at the nominal level of measurement are things like gender. You may be male, you may be female, you may be non-binary, you may be some other gender category, right? That is a nominal. We don't put an ordering into, there's no natural order of gender. Another type of variable that is measured on the nominal level is something like eye color, or something like the type of school, whether it's public, private, or charter. There's no natural inherent ordering of those categories. The other level of measurement that applies to qualitative variables are ordinal variables. Now, ordinal variables are variables measured at the ordinal level of measurement, places individuals in categories, but those categories have a natural ordering or ranking. All right. So I'll start by saying one of the examples are your Likert scales, right? If I go to a survey and they may have a prompt, and for me to respond by selecting either that I strongly disagree, I agree, or I strongly agree with whatever statement or prompt that was placed in front of me, right? Well, that's an agreement level. If I'm at the lower end from the strongly disagree, I know strongly disagree is much stronger of a disagree than a disagree. And then I get to more positive outcomes when I start to say agree and then strongly agree, right? There's a natural ordering based off of how that scale was created. All right. Now, one thing about that is that the intervals between those rankings or that ordering of the categories are not necessarily equal, right? The difference between let's look at our second example here, rubric scores, right? Where we have excellent, good, satisfactory, and needs of improvement. The difference between a good and an excellent is not necessarily equal to the difference between a good and satisfactory, right? And so what happens here is that we, with these ordinal variables, we can't get a precise mathematical difference between the levels. But these variables are all qualitative. That means they're putting individuals into a category. One has ordering, the other doesn't. Now let's go to the levels of measurement for your quantitative variables. We have interval and ratio. This gets a little more difficult and a little conceptual here. But with interval variables measured on the interval level of measurement, these quantitative measurements have equal spacing or intervals between the values, and they're numerical because they're quantitative variables. Now, I do want to make a note here. I talked about Likert scale items in this slide here, and I know that sometimes in research, individuals assign numbers to these categories, and they treat your ordinal variables with Likert scales as continuous. There's debates on the appropriate way to do that. All right. And so some individuals, depending on the number of categories of that categorical variable, treat the Likert scale items as a quantitative variable, and then you analyze those like you would analyze other quantitative variables. All right, that is okay, and there's some debate in the literature. Our fields are there's more research, more current research that supports the use of treating Likert scales as actually interval level variables, but we can talk about that more later. All right. But the interval, we have quantitative measurements. So we have numerical values, and there is equal spacing between those values. So the difference between a 1 and a 2 is the same as the difference between an 8 and a 9, right? But there is no 0 point for that variable. All right. Now, in general, 0 usually means the absence of whatever is being measured. All right. And so when we say that there is no true 0 point for interval level data, that means 0, the value 0 that variable takes on doesn't mean the absence of that property, right? And so one of the most popular examples of that is when we have temperatures measured in degrees Fahrenheit. All right. We know that the freezing point is at 32 degrees Fahrenheit. So 0 degrees doesn't mean the absence of heat. It is just a scale, a value on the scale that doesn't mean the absence of heat. When we think about IQ scores, we don't even have a 0 IQ score. And so while the person who has an IQ score of 110 compared to a person who has an IQ score of 112, that interval is 2 units. The IQ score is 2 units higher. In the same way, a person whose IQ score is 132 compared to a person whose IQ score is 134, another 2 units, there's equal spacing, and those equal spacing have the same meaning. With these interval variables, we can do things like add the values together or get differences. That's usually what we're interested in research. But we shouldn't do any division of the values or getting like ratios or thinking about something being a certain number of times higher or a certain number of times greater, because that for those types of statements or those types of conclusions, we need a ratio level variable. And so your ratio variables, quantitative variables, they are numerical. The intervals do have equal spacing, and there is a true zero. A true zero. That means that zero truly indicates the absence of whatever is being measured. So, for instance, student enrollment, right? If your student enrollment is zero for a certain day, that means zero. That was an absence of students enrolled. The expenditure or amount you spend per student, if that value is zero, that means there is an absence of that actual property, which is the expenditures, right? And so with ratio variables, we can do a division and see how many times greater or how many times less one individual is compared to another. And so those are our levels of measurement. The reason why we want to go over the types of variables and these levels of measurement is because the type of variable and the level of measurement really dictates the type of graph that we're going to make of our data. So we always want to present a description of our data, right? One way to do that, especially with quantitative data, is to create graphical displays. We can do that for quantitative variables as well. It's going to dictate the type of descriptive statistics we're going to use. So some statistics align themselves with categorical variables. Other statistics align themselves with quantitative variables. And then if we want to do some type of different types of data analysis, the level of measurement and the type of variables also come into play. All right. And so I wanted to further define and give additional examples of those types of variables and the levels of measurement. And so I'll stop with this video and we'll see you next time.